And I work for Embrapa. Embrapa is a Brazilian corporation or enterprise for agricultural research, and is linked to the Minister of Agriculture, Livestock and Food Supply. I will give some examples, very quick view of applied physics and instrumentation. Embrapa, as I said, is the Brazilian corporation for agricultural research. The budget 2014 is about $1 billion, and we have almost 10,000 employees. The distribution and scientists, analysts, technicians, and assistants, and most of our scientists are PhD scientists. We have 45 units, research centers in the country. The headquarters is in Brasilia, and we divide the centers in thematic centers, like the instrumentation center, as I am from, national product or commodity centers, eco-regional and agroforestry centers and service. We have also a very important international cooperation, international activity. We have labs, what we call virtual labs abroad, in United States, Europe, now in China and Korea, and we are going also to Japan. The partnership institutions, and this kind of initiative was created in 1998 to exchange, to organize the network in R&D and research and development, and also foresight scenarios in R&D and the perspectives in terms of markets and technology and so on. So it's very important strategy. We organize it to follow up what's going on in other parts of the world. We are presenting in all the continents, and these initiatives is a kind of benchmark initiative that's working very well. What happens in the last 20 or 30 years in the south part of the world? The most important thing was this what we call, or the economists and other reviews of Brazil used to say this Brazil's agricultural boom. Since 1975, 2011, if you look at the grain production, we increased it in 230%, the area 31%, the yield increased 151%. The meat production, the same, chicken, almost 300%, pork 150%, beef 74%. The same in the bioenergy production, like sugarcane, ethanol, 260%. So if you, in 34, 35, almost 40 years, it's increased, constant increase of almost 4, 5, 6%. There is no other activity that we could say that in 30 years have a growth rate of 5% per year. Also, the Brazilian agribusiness exports increased 300% from 24 billion to 95 billion in 10 years. And we reached the 180 markets. As Dr. Caiado said, we are the third one in the world exporter. You see that's a big revolution, what we call a silent revolution, in the field and in the tropical area. If in the next 4 months, if you go to the central part of the country, you'll see harvesting soybean, you'll see cornfields, you'll see harvesting cotton and soybean fields like that. I was born in a farm near to here, about 80 miles from here. And 40 years ago, my dad used to show pictures like that from the United States, the Corn Belt in the United States, and we are very admired of those kind of views, image, pictures. And now, 40 years later, we can see the same images here in Brazil. So it's a big progress, and important to look at this in more detail. And you see here harvesting soybean, the harvesting machines, and just a few meters behind, sowing corn, second harvest. And no tillage, we don't plow, we just do this tillage, direct tillage. What is environmentally friendly. So the combination, so you see corn right after soybean. Combination of scale, mechanization, genetics, agrochemicals. 2 crops in the same year without irrigation. So differently of the United States, the central, the Middle East of the United States, where we have just 1 harvest. We have double cropping here. 2 crops in the same year without irrigation, only in Brazil. And we are supplying, as a consequence, a competitive meat industry, as we'll see in the follow slide. But also important to say the importance of family farming in Brazil. You see the numbers here. And the importance in cassava, poultry, beans, and so on. So we have 2 very important agricultures. One is the family farming, and also the enterprise agriculture. This figure is easy to see what happened from 76 to 2010, 11, and is continuing the next years up to 2014. Evolution of grain and oilseeds production, productivity, and area. Area in red. In blue is the production, and in green is the yield. You see what happens here. In these years, the big progress. And the most important is to highlight the yield production, the yield increase. The yield increase is explained 70% by science and technology. So we increase the production per area. Practically, we increase only 30% the area, and we increase 230% the production, and the explanation is productivity, is intensity, is technology applied to the agriculture. So this is fundamental to say. The same here, if you look at the meat, bovines, chicken, swine, you see the same behavior, the increase. And this combined expansion of meat production and industrialization in Brazil leveraged the country to the #1 position in exports worldwide. while keeping the domestic market, which presents a high and growing per capita consumption. So it's a big challenge to supply the domestic market, at the same time export the what we have besides the domestic market consumption. Also, if you look at what we call the Caatinga, the semi-arid part of the country, 10, 15 years ago, and now. This is due to the irrigation, the water supply to that area. Dr. Caiado also, in a different table, showed us the importance of the Brazilian production and exports. It's #1 in sugar, in coffee, in orange juice, soybean grain, beef, chicken, second, and so on. In export, you see the numbers. So we are #1 and #2 in the red numbers here. And it's important also to pay attention to the numbers. All of them are $1 billion. So it's a big, it really is the most important business in the country. It's agribusiness, as we can see from this figure. I will use some of my time now to show some examples of applied physics and instrumentation to agriculture. That is our research center, Instrumentation, Agricultural Instrumentation Research Center, located in São Carlos, like Egrios, Dr. Caiado. And it's very close also to the University of São Paulo, the Physics Institute there, as Dr. Tito Bonagamba is here. It's a pleasure also to have you here in this presentation. And as Dr. Caiado showed us, the nucleus of the Instrumentation Research Center came from, was nucleated, this research center at the Physics and the Escola de Engenharias, the engineering school of São Carlos, ESC. So that's very important to pay attention of this hub of science technology, and now also the companies, private companies, around this or the neighbor of those research centers. We have 30 researchers at that institute, 9 physicists, electrical electronics engineers, material engineers, chemists, agronomists, chemical engineers, mechanical engineers, chemical pharmacists, and economists. One is R&D director at this moment, and the other one is in our Labex, in our lab in German, Jülich. We have 84 employees and about 300 collaborators per year, undergraduate, bachelor, master, doctor, postdoctor collaborators. That institute is important in terms of intellectual property production. Not only sensors, equipments, and softwares, modeling, simulation, and so on, but also invention patent, utility models, softwares, trademarks, industrial design, and we are going to reach 100 assets on that issue of intellectual property. We have licensed and granted patents in different countries. Also, we licensed 29 technologies, and several startups and private companies were created from this, from the institute there. Dr. Caiado told us about the Egrios, is used in one of our developments there, and we are a partner on that enterprise, in that initiative. If you look at the labs, we hold there electronic development, precision agriculture, imaging modeling, nuclear techniques, nuclear magnetic resonance, thermal photoacoustic, optics and photonics, nanotechnology, microscopy, agroenergy, and spectroscopy, spectrometry, and chromatography. All of those labs are related directly to physics. I will give some examples of application. We developed that robot for data logging. You see on the right picture, taken Dr. Lukiar is here. It's a part of a partnership with Agricultural Research Service in the United States. Dr. Shepers and Dr. Lukiar developed this technology to sense the status of nitrogen on the leaf. And this is very important for the management of the cultures like corn and other plants. It's very critical, the amount of nitrogen and the need of supplying or not nitrogen. There's a big issue. It's very expensive. Nitrogen we have problems, environmental problems, if we don't use in the right way the nitrogen and so on. So this is one of the examples. That's the AEOS partnership. Dr. Caiado explained in details how does it work, but it's a kind of methodology for mapping disease in citrus and maybe other crops in the future. The other technology we are taking advantage are the drones using processing like hyperspectral sensors, and using this that kind of drone. And one of the applications is precision in precision farming, precision agriculture. You can see here the presence of nematodes in red, and the soil, the exposed soil, and the soil being cropped. So it's crop covered here, but you see failures or defects or problems, and this is very important to take decision what to do when you have this kind of, or the presence of weeds in the exposed soil. So that kind of instrument and equipment is very useful in the practice of the agronomists, for instance, or to the producer in the field. It's important to say we have large areas, like in the central part of Brazil, like millions of hectares in soybeans, millions of hectares in corn and cotton and pasture and so on. So it's very critical. 2 or 3 or 5% of this amount is a big impact in terms of cost or environment. In soil and water management and conservation, we have several methodologies and equipment designed to determine the physical and chemical properties of the soil, like the soil compaction. Penetrometer is a big issue, also the compaction of soil, because the use of machines, the agriculture, very intensive agriculture, we have as a consequence the compaction. And now we have studies very recently showing that the nematodes, for instance, is dependent on the compaction of soil, the root system and the the amount of roots will depend of the water, depends on the nutrient and also the diseases. So it's sometimes the physiologists try to solve, or the people working fertility try to solve fertility or try to solve the plant, but the problem is in this case it is in soil physics, is in the physics. And that is very important result we have in the last months to explain problems in the central part of Brazil, in soybean and corn and cotton. And the deficit in fertilizers or amount of customers is very high, as I told. Also, we developed a generation of four generations of CAT scanners, tomographs, homemade tomographs. We started in 1986 with a homemade CAT scanner, gamma ray. Again, in 1994, a field tomograph, portable tomograph for trees and soil clods. You see here in use. We developed in 1997 a microtomograph, first generation, a third generation tomograph in 2001, and also we acquired now a microtomograph in 2008. And now we are also starting scanning soil samples in nanometric resolution. This is another kind of application of an MR spectroscopy to evaluate the oil seeds for biodiesel production. Online evaluation is another application, very important to select the best seed in a non-destructive way. Otherwise, you find the best seed, squeezing the seed, crushing the seed, and we don't have the seed, and you discover late that is the best seed to plant to do this improvement, the genetic improvement, but the seed is dead. So it's very important to have non-disturbance, non-destructive methods like this one. The other area of interest and application, and we are the leader of National Research Network, is located there in the National Laboratory in Nanotechnology applied to agribusiness. We have been working on several composites of nanoparticles and nanofibers, different ones from many byproducts of agriculture. Some of them are residues or considered not like garbage and things like that. So we are using the techniques to investigate, to look at the details of the matter and reconstructed this using materials from agriculture. We have several different applications and use of raw materials, and this is a very important example how you can add value to the product. Sometimes we have products with no value, and here this is application for the automobile industry or avionics and other application, and adding value to this raw material using nanotechnology. Another important one, this is the previous presentation from IBM was showing us the importance of nanotechnology and what we call smart agriculture or smarter devices, as you said. So the smart agriculture is becoming a very important issue for us, like the big data, the analytical big data, and the sensors, and the Internet of Things. And connecting all of this together, integrating the technology to take best decisions. This is very, very important when you say about in a business of billions of dollars. And it's important to say that the Brazilian agribusiness is 25% of our GDP. So it's by far is the most important business in the country. And Dr. Caiado is very bright, and he followed that very well. And I saw the IBM, and one of the issues is natural resource, and the other one is health. But natural resource is the most important ingredient we have in the country. And it's important to learn how the process, how the system works, and to learn how the system, very complex system, we need to use the best tools the humankind has to approach and take advantage of this richness we do have. They control release of water and fertilizer, what we call the intelligent or smart fertilizers. We are developing the urea and the gel that is used in agriculture for water. Water is a big problem. We are facing the southeast part of the country, but we know that water, food, and energy, the economists never, in general, they don't agree themselves. And now they say, all water, food, and energy are the three big issues humankind didn't solve yet. So it's very important to release water to the plant in the right rate as the plant needed. There's another example, edible fumes. Chitosan and zinc are proteins from natural proteins. And we have examples like in apples that we improve the shelf life lasting 20 to 25 days, adding time to the shelf life of apples. And to finish, we are working very hard in a partnership with the University of São Paulo in São Carlos to develop this kind of equipment. It's a rover plus lips, as the same technology Dr. Caiado told us before, using laser, breakdown, spectroscopy. And interesting that we are using materials from agriculture, corn, and sugar beets to feed a 3D printer, and we are printing the pieces, the parts of this portable or mobile platform. And we have inside the lens, lasers, optical fiber, and so on. And we did the first proof of concept and this organ. And we are having this national symposium in November. We are preparing this to show that. I call this curiosity of agriculture because the curiosity marked. Okay? So integrating lots of technology and fabricating the parts of this device using agriculture materials. This is the integration of technology or the smart agriculture. You see the hoser, the laser, getting the spectrum of the soil, the plants, or the leaves, the crops, the vents, the people in the computer, integrated all of this. So this is the big issue we are facing at this moment. Thank you.